Number 3 says to perform an experiment, you need 0.300 liters of 6 molar nitric acid. You go to the acid cabinet and discover that you only have 100 milliliters of the concentrated nitric acid. Will you have enough acid to complete the experiment? Show your calculation and explain your answer. So, to perform our experiment, we need, so that's telling us that our final volume and our final molarity. This is what we need. So once we do our dilution, we need a V2 value of 0.3 liters, and we need an M2 value of 6.0 molar nitric acid. We go to the acid cabinet, we have 100 milliliters. This really doesn't help us much to know how much we have. That's not how much we need to produce our 0.3 liters of 6 molar nitric acid. That's just how much we have left in our bottle. So it's not really helpful right now. We need to figure out what our V1 value is. And then we need to compare to this 100 milliliter value that's given to figure out if we actually do have enough acid. So let's write out our variables here so we can kind of think this through. We know we need M1, V1, and we need our M2 and our V2 values to do our dilution equation. So we said we have our M2 value of 6.0 molar and our V2 value of 0.300 liters. I'm going to go ahead and take this liters to milliliters because it tells me I have 100 milliliters of my acid left. So to be able to compare my V1 value with the amount that I do have to work with, I need them both to be in milliliters. So 0.300 liters, I'm going to go ahead and convert that to 300 milliliters is my V2 value. We need to know what our V1 value is going to be, and I'm going to use milliliters, so my answer will come out in milliliters as well. And then our M1 value, well, that is given in our table, so we do need to refer up to our table that tells us what we have in our stock room, what we have in our store closet to use. So nitric acid, if we look at our table, nitric acid, we have a stock solution that it has a concentration of 15.9 molar. So there's our M1 value, 15.9 molar. So now that we have all this information, we can use our molarity equation, our dilution equation, solve for our value for V1, and then we can determine if that V1 value is less than the amount we have. So if we need less than 100 milliliters, then we can actually do this experiment because we'll have enough nitric acid. If we need more than 100 milliliters, then we're not going to be able to do this experiment because we don't have enough of our acid left to do it. So let's go ahead and solve here. M1 times V1, so 15.9 times our V1 value, which we don't know, so we'll leave our variable in, equals M2, 6.0, times our V2 of 0.300, I'm just going to put 0.3. To solve for V1, we'll divide by 15.9, and if we do it on the left-hand side, we also have to do it on the right-hand side of our equation. That leaves our V1 equal to 6 times 0.3 divided by 15.9. And so when I do that, I got, let's see here. Oh, and I actually made a mistake here, and I noticed it when my answer came out less than I expected. So I accidentally put in the number of liters instead of using my milliliters like I said I was going to. So 6 times 300 divided by 15.9. Let's try that again. 6 times 300 divided by 15.9. And so when I did that, I got an answer greater than 100. Before, when I did it, I got an answer of 0.1, and that didn't seem like enough volume. So now I got my V1 value to be equal to 113 milliliters. So that's my number of milliliters. So I need 113 milliliters. I only have 100 milliliters, so will I have enough acid to complete the experiment? The answer is no. So if we were to explain this, we might just say, to do this experiment, I'll abbreviate experiment EXP, we need 113 milliliters of acid, but let's see, but we only have 100 milliliters remaining. So we will not be able to do this experiment. We can not do this experiment. All right, there is our descriptive answer. We showed our calculation and we explained our answer here. Looking at number 4, it tells us that we mix 125 milliliters of an unknown concentrated acid with water, and we get 1.5 liters of 1.5 molar acid solution. What type of acid is it, and how much water is used? So let's start with what type of acid is it. Well, because we have this table that gives us a whole bunch of molarities, if we can calculate the initial molarity of our unknown acid, we'll be able to compare to the values in the table to figure out which acid it is, or which base it is. It actually tells us it's an acid, so we can go ahead and eliminate ammonium hydroxide because that is not an acid, that's a base. So it has to be one of these ones down here. So let's go ahead and kind of label pieces in our problem. We mix 125 milliliters of unknown acid with water. So this must be our V1 value. It's our amount that we mixed with the water. We get, so that's telling us that that's our second thing, our V2 and our M2 value. We get 1.5 liters, so there's our V2 value, of 1.5 molar acids. There's our M2 value. So let's go ahead and write out our variables. M1 V1 equals M2 V2, and let's write down our information here. Our V1 value is 125 milliliters, and our V2 value is 1.5 liters. I'm going to go ahead and convert that to milliliters, so that would be 1,500 milliliters. I do need my units to match up before I can use my dilution equation, which is why I knew that I needed to convert to milliliters. Or I guess I could have converted the milliliters into liters over here and left my liters. But I do need the same unit of volume and my V1 and my V2 values. Now my M2 value we know is 1.5 molar. And we know that we are looking for our M1 value, which will then help us determine which acid. Okay, so let's substitute this in. M1 V1 equals M2 V2. We don't know M1, so we'll leave that in there. Times 125 equals M2 1.5 times V2 1,500 milliliters. To solve for M1, we'll just divide by 125, and if we do this on the left-hand side of the equation, we also have to do this on the right-hand side as well. So our M1 value is going to be equal to 1.5 times 1,500 divided by 125. And when I did all that math, I got an M1 value of 18 molar. So now let's look up at our table and figure out which acid has a molarity of 18 molar. And so the only acid that has that molarity is sulfuric acid, so H2SO4. So the acid that's used, that acid is H2SO4, or you could have written out sulfuric acid. Either way is totally fine. The acid used is H2SO4. Now the second portion of this question asks how much water is used. So we know when we dilute something, when we perform a dilution, that we used some small amount of our concentrated acid, in this case some small amount of H2SO4, and then the rest of our solution is made up of water, H2O. And our total volume here, we actually have our initial volume and our final volume. So our total volume we want to be 1,500 milliliters, so that's where we are up here. And then our initial volume, the amount of H2SO4 that we used, is 125 milliliters. So that's what goes down here, 125 milliliters. So if we use 125 milliliters of H2SO4, when we need to fill up the rest with water to get up to a total volume of 1,500 milliliters, all we do to figure out how much water we need is subtract 1,500 milliliters total minus 125 milliliters of H2SO4. So if we perform that operation, I got 1,375 milliliters of water, of H2O, are needed. And we will go ahead and box that answer in since that is the second portion of this problem.